Aloha everybody, this is Gigi from Kauai Community College. In this video, we'll be talking about graphing by transformation with exponential functions. All right, so let's get started here. Suppose you have the function g of x is equal to 2x to 2 to the x plus 3 minus 5. So when staring at this function, we can see that the parent graph of this function is 2 to the x power, and that is an exponential function. So let's go and graph the parent graph. Okay, so when x is 0, 2 to the 0 power we know is 1. When x is 1, 2 to the first power is 2, right? So we have the point 1, 2. When we go to the right 2 to the second power is 4, so right 2 up 4. When we go to the right 3, 2 to the third power is 8, so you have 3, 8, and then 4, 16, and so on. So as we move to the right, the function is going to increase exponentially, the exponential function, right? So with the base of 2. All right, so as we move to the left, negative exponent means the reciprocal of the positive exponent. Or we would say positive exponent is repeated multiplication, so negative exponent is repeated division, right? So, we have the inverse of, or the reciprocal of 2, which is 1 over 2. And then 1/2 divided by 2 is 1/4. So 2 to the negative 2 power is 1 over 4. And so on. You'll get like 1 over 8, 1 over 16. And it is going to get smaller and smaller, closer to 0, but not approaching 0. So when we are graphing this, we notice that the locator point, which is a very important point on the exponential function, and that is 0, 1. Because any base that you have to the 0 power will be 1, and then negative exponent is going to flatten out to 0, and we call that the horizontal asymptote. Okay, so those are the two important characteristics of an exponential function. It has the locator point of 0, 1, because anything to the 0 power is 1, and it has a horizontal asymptote at y equal to 0 because negative exponent will get really small, close to 0, but never really become 0. All right, now so let's go and graph this function that we have. Looks like it is being, the parent graph of 2 to the x is going to be move to the left 3, down 5. So let's move left 3, down 5. When you move down 5, your new asymptote is going to be at negative 5, and then you move left 3. That gives you that new origin there, but it's not the locator point. The locator point is right at the origin, go up 1, because anything to the 0 power is 1, right? So that's the locator point right there, and then you would go 0, 1, 1, 2, 2, 4, 3, 8, and so on. And if we go left 1, negative exponent, so we'll have the fraction 1/2 and 1/4 and so on. So going to the right, it's going to increase really fast, and going to the left, it will be decreasing, and it will flatten out at y at the asymptote there. All right, that is the graph of an exponential function using transformation. Now, when looking at this graph, we notice again that it has a horizontal asymptote at negative 5. It does have a y-intercept right there. Right, so we can actually go find that y-intercept. Y-intercept is when x is 0, so we plug in 0 for x and we get 3. So the y-intercept is at 0, 3, right there on the graph, which is pretty nice to recognize, but algebraically that's how you would find it if it's not too nice, right? And then it does have an x-intercept right there, How do we go and find the x-intercept? Well, x-intercept is when y is equal to 0. So we do have an onion problem. And that is why we did onion problems before this graphing unit. Let's solve for x. Add 5. And then to undo exponent, we use log. Log base 2 of 5 is equal to x plus 3. And then you subtract 3 to the other side to get x by itself. And I kind of like writing the negative 3 in the front rather in the back because it looks like log base 2 of 5 minus 3 if you write it in the back, right? So I like to write that negative 3 plus log base 2 of 5 just like that, just to have it look a little bit better. All right, now so the the x-intercept would be right there at negative 3 plus log base 2 of 5 comma 0, which is approximately negative 0 point something, but you know, if you want to get an approximation. But the exact answer is that right there. Okay, that is how we graph log functions, exponential functions. Now, if the base is 3, we would go through the same actual process, go graph our parent graph, and the locator point again is still going to be 0, 1, and you still have a horizontal asymptote at y equal to 0 for the parent graph. Now the other side points, the white dots, are going to be different because the base would be different, but as far as the shape go, it's going to be the same shape. All right, and that is it.